Thanks, everyone, for sticking around until the last session. You know what they say, it's only the really dedicated people that really want to be there who are remaining for the last session. Pretty awesome. And you were promised drinks, so there's that. When you have a global cloud, that kind of puts some new and interesting perspectives on your work. It gives you the opportunity to fail in all the old ways, plus some new ones. And when you are in the cloud, as you all know, you can deploy anything, anywhere, at any time. And if you're not careful, you're going to do it over and over and over again. Or you do the thing which is on the bottom line there. And here's the thing, whenever you say that word, you have to say it 3 times. It's like an incantation, right? So you can't just say it once. You have to say automate, automate, automate whenever you say that. Otherwise, you know, you'll have bad luck and things like that. Of course, also in the cloud, you have ultimate power at your fingertips until you receive your credit card statement. So these are all just obvious factual statements in the beginning of a talk, right? A lot of my work is in this space, sorting things out for people who don't know, enough. They don't have the experience and the skill set, and that's fine, that's fair. You don't in the beginning. It's okay to ship something which is sloppy, but it's not okay to remain sloppy. And before I actually talk about you guys, I just want to call out real quick to the sponsors. Thank you, sponsors, for making this conference happen. And also, of course, the organizers for organizing a really great conference. Amazing times. I have a question for you guys, a data point which I have been tracking for all my presentations over several years. And the question is, I used to ask the question if you have an Azure subscription, and that used to be the case that not everybody did. But I'm going to go ahead and assume that nowadays everybody actually does have an Azure subscription, at least one. Some of us have very many. But the question is simple, and by show of hands, yes, I have something running in production in Azure right now. That is almost half the room, which is, pretty impressive. So we are getting there, and this number is steadily going up. We're getting more and more people saying that they are, in fact, running things in production in Azure. I think you all know I'm Magnus Mårtensson, and yes, I was the first person to become an Azure MVP in the Nordic countries, so I've been with the Azure cloud since a long time. Actually, number 2, the second person to become an Azure MVP in the Nordic countries is my good friend and colleague Alan Smith, who is also present and presented this morning. And to his credit, he was actually an MVP before in other titles before me, so I started as an Azure MVP. But Alan has been around, so he's the real heavyweight here. I'm just for show. By the way, in case you don't know what a regional director is, neither do I. Microsoft Regional Director is a funny title because it means, I don't work for Microsoft. I don't have a region and I don't direct anything. So. It's a little bit funny, but yeah, it means that I'm very close to Microsoft and that I talk to them a lot on very high level, and we discuss all kinds of funny things, like for instance the recent reboot of Azure just in the beginning of January. Everything in Azure redeployed, or actually in fact everything in the world redeployed, which was a funny incident of sorts. Yeah, apart from that, you can reach me anytime, anywhere. Send me an email, etc. Tweet me something nice, make me happy. I run my own company called Loftysoft, by the way, as a consultant. And of course, I have to mention the GlobalAzure Bootcamp, but I do believe that everyone in here knows what that is. Send a note to all your friends about this. Make sure you organize these events, make sure you attend these events, and let's have fun on the day. My topic today, by the way, it's actually, this is good, actually. When you want to talk, do you know this trick in PowerPoint that you can hit B for black screen? Actually, you can do white screen as well with W, but that means you can do like shadow figures and stuff. But with B, it's cool because then you can talk. So I have 45 minutes, and I've already wasted some of those minutes. And I'm calm, it doesn't matter how much content we actually cover during this session. We have this time together, so let's enjoy it and talk a little bit about architecture. We all love that stuff. And not stress about it, because there's never going to be enough time. You know, I deliver 40-hour, Monday through Friday, 40-hour training sessions, and at the end of a week like that, everybody's like, yeah, well, there were these other things we wanted to talk about, and then some more things, and so 45 minutes. We're going to cover the things that we were able to cover, because we have these bad people that only give us, 45 minutes to talk, and I think that's pretty bad of them. But yeah, it's life. We'll have to roll with it. So I'm just going to ignore, stressing out about which, how many slides are we able to process. We're going to start actually having a little bit fun together. We're going to make a competition between the room and these guys up front who think they're really good, right? So here's going to be a question coming up, and you guys will have 3 chances to answer. If you don't get it right, we'll let these guys see if they are smarter than you. So see if we can nail them. In the cloud beginning, of course, there was Amazon Web Services, as we all know, right? And what year and month did Amazon Web Services go general availability? General availability. Anyone? Anyone? No, Googling, no, come on. Play nice. No binging either.
This guy don't specify rules.
So, anyone? Shout out a month and a year. Is this thing on? June 2010 is not correct? 2006 is correct. Month? No.
Hey.
No. Okay, front row. March. 2006 March. So nobody. Nobody got it. All right. And then after a while, we had Ray Ossie coming on stage for the very strange PDC that they put out the agenda with all the sessions, and they had the keynote where Ray goes on and he says, so I'd like to announce a new service in the cloud, Windows Azure. He just casually drops it like that. After we exit the keynote, I was in that room. After we exit the keynote, they had changed all the schedule and there were new sessions, and it was one of those secret reveal things. When was this PDC? 2008 is correct. And when did Windows Azure, as it was called back then, go general availability? What is the actual birth date of Azure? February 2010. That is absolutely correct. Fantastic. So we got some people here with some knowledge of history.
You want to come here?
That's great. So February 1st, 2010 is the birth date of Azure. All right, so we had Amazon and then we had Azure, and the third one is correct. And so there are many reasons why these 3 have won the day, why these 3 are the 3 public clouds and all the other ones don't stand a chance to compete. It's got to do with lots and lots of money, of course, the massive investment that these 3 have done, but it also has to do with things like this. This is a map showing some Microsoft network coverage, and I don't know if it's up to date or current or anything, so I put it in quotes, the whole map. So just it's a reference just to, as a discussion point, that these 3 companies, Amazon, Azure, and Google, they have spent so much money buying up all the black fibers that exist in the world, and so they basically own them all. And all the ones that are being currently built and all the ones that are being planned to be built, they've already bought those as well. So it doesn't actually matter if any of the other data centers have good offerings. They're not going to be able to talk to anyone, so it's fine, right? It's because of things like this, because of massive investment, that these 3 are the ones. If you look at such things as the infrastructure as a service investments, public numbers from these companies, you will see big, pillars for these 3 companies, like massive amounts of billions of dollars, and then you'll see the 4th investor in this space being a little bit of a pillar like that. So you just look at the numbers, you know that this is the actual truth. And also, if you think about the cloud, it really means the largest IT migration in history. We're moving everything right now. And that was the hockey stick thing that happened, it's actually quite many years ago now. Before that, we, or any analysts, anybody, nobody had really thought that companies would take all their stuff and move to Azure. They'd be like, yeah, they'll have some services in Azure, and then they'll have their own on-premises stuff, or so on and so forth. But what happened was that it changed, and everything is moving. So really, this is the largest IT migration in the history of our industry.
So who said that brilliant sentence?
Yeah, that was me.
Okay.
Yeah. And also a fairly new thing now, if you talk to Microsoft, now you can have a new title now. You can be a cloud developer, whatever the heck that is, but now it's a thing, right? So you can actually be something called a cloud developer. So it looks like you're migrating to the cloud. Would you like some help with that? Is sort of that's where we find ourselves. And as you all know, we get a picture like, I think you've seen this picture, many of you, right? Or a version thereof. They keep incrementing the number of regions on the bottom there and basically adding maybe a new service here and there. But we get a map like this. And also, it's one of those eye charts, right? It's like cover one eye and read the fine print at the bottom or something like that. There's so much. A picture like this is about giving you a sense of, oh my gosh, there are so many things. But a lot of people are sort of in that space, and they don't know what to do with all of these resources that are available. So I'm going to go into Visual Studio Code here. Is it big enough? No, let's make it bigger. I'm going to go into Visual Studio Code, and I'm going to, in case you don't know you can do this, you can sign in, which I already did. And you can get a list of all the resource providers that you are able to take advantage of. So I'm getting the list of the resource providers, and you can see if you scroll this list here that there are a bunch of things in here. Some of them are really interesting. There's actually a resource provider in here called, let me see, where is it? I think it's up here. DocumentDB. There's a resource provider called DocumentDB. All of these resource providers are they correspond to the services that you can create in Azure when you basically go and press plus and then type something and create a service. So in order to be in Azure, any service needs to implement this resource provider contract. And it appears that that there isn't a Cosmos DB resource provider. In fact, it's still called a DocumentDB resource provider. It's kind of interesting. There are other things in here as well, and you can see also here that the event grid is not something which is registered. It's not even. It was not registered, but then I registered it and unregistered it, and now it's unregistered. And what does that mean? Well, it means that if you're not using a resource provider, there's no reason for you to have that context in your subscription. So if you're executing a template or something sometime and it doesn't work, it can be because you're not really caring about that context until now. So you might need to go and register a resource provider. I'm going to show you how to do that. Also, there's one more in here in the list that I thought was fun to see. There's one called myget.package management. Yeah, resource provider. Pretty cool. Yeah, and he's right here, Mr. NuGet, or myget, sorry, NuGet. So let's see how many we have. Let's do a measure on this thing and see. So we got 123 resource providers that I have available to me right now. And this number keeps going up. It was 100 a while ago, and just adding more services all the time. And it's actually interesting that some of these resource providers, you know them, like ClearDB, etc., they're not from Microsoft. They're partner offerings, other offerings in the cloud that implement the same contract and can be provisioned, SendGrid and these things, can be treated exactly like the services that are offered by Microsoft in the Azure platform. So the event grid, if I get that provider namespace specifically, and they're going to come back and say, well, this is unregistered. You're not using this thing. So what you can go and do then is to run this register command, which will, and it takes a little bit of time, but it will bring that provider into context for you in your subscription. All right. So I just wanted to show you how many there are and the fact that you can actually list them and see what is available as a list of text in this case, and not just browse the portal. Right. We were going to talk about architectures here, and we're going to discuss a couple of things to, how to make, I'm going to tell you a story, and we're going to talk about how do I make my architecture more global, because this is a big knowledge gap that we are seeing, people who work in this space, and I think all of us agreed on the panel, etc., that this is a big knowledge gap here. Another fun one. How many remember this one? How many deployed this? Have you deployed this? I know Martin has. He still does. This is the original architecture for Azure, the first one. The very, very first one, when it was called a hosted service, the thing which is now called a cloud service in Azure, where you deployed web roles and worker roles. So this was the first architecture, this disconnect between the front end and the back end and kind of thing that we had, platform as a service. So, this brings back good old memories. So what we are doing when we are moving things to the cloud, what we want to do is take maybe an old product that we had and turn it into a service. We used to be a company that created a product that we shipped and installed at our customer's location, and now we don't want to do that anymore. We want to instead create a service. And of course, this concept is called multi-tenancy. And I was challenged to find a good picture for this. So, when in doubt, always, of course, turn to Monty Python. And so the Holy Grail will symbolize multi-tenancy. That is the thing we want to achieve. That's the end goal for architecture. If we can build something, a service in the cloud, which is the same service for all of our customers, there is actually, and we can make that work, and we can make that scale, and we can make that global, well, then we can make a lot of money. So yeah, that's what we want to do. And here's a real example. I'm going to tell you kind of like a story here from a customer case. And it's important to remember with this story that if you have a big challenge, maybe you use a big tool, but if you have a small challenge, maybe you find a simple solution, as simple as possible. So in this case, we had a company that deployed code for their partners, and then they wanted to display their logging information to the partners for them to debug. So basically it looked like this. They had this on premises first running. On a Windows server, they installed their service, and then they installed their partner's code onto that service as well. So this is code written by a third party. They were selling their offering, they were selling their service in a partnership model. So the partners were co-selling with them and helping the customers to integrate. And in this integration process, sometimes it turned into a little piece of code that was running inside of this process. But as with every other piece of code ever written, not by us, by somebody else, that code sometimes can have issues. So they wanted to extract the logs and see what happens, what is going wrong here. So they wanted to get the logs out to this developer guy, so that he could consume these logs and find out what was wrong and update the code and deploy a new version and such. And because this service also had, it's a classic deployment case of having an app server and a SQL server, and then as part of the deployment, like this is like 95% of all applications before the cloud kind of look like this. From an architectural perspective. And because they already had that server with the application data, and they wanted to surface these logs to the developers, the partner developers, it made perfect sense to create a database for these logs because they already had the tool. So, might as well use it for that. And so you got a log table. How many have had a SQL log table at some point? Yeah? Yeah, several are admitting to the fact. And I think we're in really, really good company because this is the way that, it's right there. It's a simple solution. We already have the database server. Why not just use it? Okay? And then you take this solution to the cloud. Yeah. First of all, maybe we don't want all of those servers in the cloud. So that this deployment is actually running for some of the customers that have not yet, graduated, migrated, moved over to the platform service offering. But you could pick up these 2 virtual machines and deploy them in the cloud, no problem. So you have many instances of multiple servers running in the cloud. Okay, fine. So let's start to optimize. The first thing we might want to do is just pull out all the logs and maybe just put them in one database instead. Because what we want to achieve here is the removal of that SQL server. If we can remove that VM times n, right, we got n less VMs to worry about. I got 99 problems and virtual machines ain't one. So let's remove those ones and move those databases instead into a SQL pool that you can use. And this customer case, they have over 500 databases, so it's not massively huge, but it is still quite decent sized. It's a respectable number if you have more than 500 databases. So they have SQL pools. They actually have several because they have them in different geographical locations, but roughly in the range of like 500, almost 600 databases. So now they got rid of all those VMs, or half of the VMs are now gone. Brilliant. And then they had all the logs in a big database that all of them shared this database. They had each customer had a different table in the database. Perfect. What's the problem with this picture? Anyone? What's wrong with this picture? Doesn't scale. So if you have all of us writing to the same log database, everybody's writing logs to the same database, and one piece of code that somebody wrote maybe, isn't so nice. So it's writing all of these massive amounts of log messages, You have instances where these partners are logging like, 40 million rows per hour and crazy things. Like, why on God's green earth do you actually need that many log messages? They think it's good to have, but they never really look at them, but they just do it anyway. So when they do something like that, of course, that can affect performance for all of the customers all of a sudden. Yeah, right. So we have created ourselves the thing we know as a bottleneck. And at that point, you just feel like opening the cork on that thing and just, becoming a hobo living under a bridge and just, I'm not doing this anymore. But stepping back, so they didn't have a difficult challenge. It wasn't huge, If you have a really big logging challenge, you might need a larger tool. But if you don't have a huge logging challenge, you might need a more appropriate sized tool. Let me put it that way. And in this case, they also had, and it's not in these pictures, but they also had this configuration source to the side. So all of these instances all reach out into this configuration source and read out their configuration connection to the database, these kinds of things. And so they were able to use not just one instance of the following service, but many instances. So the table storage was something that we proposed in this scenario. Maybe you log to the table storage instead, because a single table can, cover about 500 terabytes of data, so that's enough. One row in a table can be 1 megabyte in size, probably well enough for a stack trace and some data that you have from an exception or similar. That's not a problem. There's like 255 properties that you can have in one of these big Azure tables. They only used about 10 or something, so fine. Now, with transactions and target throughput, that's where they kind of hit a snag, because they had so many so that they actually needed to use more than one Azure table for the logs. And that was fine. Again, they had the configuration set aside so they could configure different customers to use different tables. No problem. And also, for a partition is a concept inside of table storage, and for one of these partitions you also have entity batch transactions, so you can write multiple log statements in one go into the table. So performance-wise, they were good. So instead of doing that thing where they have this bottleneck, they created a partition in the table for each customer, or each customer code piece there uniquely identified, and they had their own logging space to log to. So they could all spread out across this vastly huge, large, mega-sized table and not affect each other performance-wise. So really, really handy, and it's just you know, it's not a very super complicated example, but my point here is this is stuff that people don't know, right? This is knowledge that they don't have. You can't build a solution based on a piece of knowledge you don't have in your company, right? So they were stuck with this, you know, database thing and the performance and customers calling and asking about performance, and so really it's about knowledge, it's about learning. Let's take maybe kind of a shorter look at a larger scenario. Another customer, they were running Service Fabric as a global architecture in 3 geographies around the world. In this case, Western Europe, Eastern US, and Australia, Eastern Australia. They were running Service Fabric in multiple geographical locations, and they have a chart for this that looks kind of like that. And the 3 big boxes are the different geographical locations. So at the very top of that, let's see, okay, that's not gonna work well, hang on. I'll do it like this. All right, see if we can, yeah, reasonably, okay, so they have the traffic manager to direct the traffic geographically. So if you are in Europe and you hit the service endpoint or you hit the URL, it's highly likely that you will be considered to be closest to the European deployment, and you will be connected to the European version there. So the traffic manager points to all of their web assets that they had in each region. They also had, or they also use the Key Vault, and they use all kinds of logging stuff, Security Center, and all these things, the Azure DNS. Those are things that they use kind of on a global level across everything. And within each region then, they would deploy an application gateway through which traffic would come towards their deployed Service Fabric deployments with 2 node types. So they would have a front-end node type, or a primary node type, which ran their own services plus the Service Fabric services, and then they would run this other pieces of code, other people's code, in this case as well. Actually, they would run on this separated, closed-off other node type. So kind of a larger situation there. They also uploaded a bunch of media images using Azure Storage, and again, lots of SQL databases and virtual networks, of course, configured to only allow traffic specifically going through the application gateway into the specific addresses of the services running inside the cluster. So this is a little bit more evolved. And in fact, they're using quite a lot of these services in Azure. Oh, excuse me. That's a quite a bit larger architecture, right? Let's hop along quickly into global data. The thing is that as you saw in my example there, it's quite easy to put up the multiple auto-scaling web front ends in multiple geographical locations, and that traffic manager thing. That's usually not much of a challenge. It's actually quite easy to do, and since it's platform services, you can just turn that on and it actually just works. No problems there. Really not difficult at all. But something which is more difficult or more challenging is to globalize your data. How do you make sure that your data is readily available everywhere at all times? Difficult to do. So let's start with something simple, but really a powerful pattern, which is called the materialized view pattern. I think many of you know that in Azure you can go and select a database and then you can geo-replicate it. I did that here. I've actually set this up. Oh, by the way, I can show you in the portal. Yeah, here we go. A little bit small. Let's do a zoom again. I have multiple database servers, 3 of them, and then I have multiple databases. So I have them in West Europe, Australia, and East US. Just as a demo thing, and I could go in here and look at the picture here, but I have it as a screenshot just in case, you know, of time and such. You set up the synchronization for your database. You can have up to 4 additional locations for your databases around the world, which will synchronize your data from one master database to all the other ones, and you can do failover and stuff. All of that is just built in really by just using the SQL Server, SQL Azure, SQL database offering in Azure is the appropriate name to use. So you can do this failover stuff. Okay, cool. What that means is that you will have to pay for all the databases in each location, right? That's a cost that you're going to have to carry. Plus, there is this latency thing, because if you update data in one of the databases, it's not automatically, magically, instantaneously going to show up in the other databases. There's going to be eventual consistency in your system. And so, one way to tackle distribution of data would be to use the materialized view pattern. And I've seen that used with Azure Table Storage. I've seen it used with blob storage. It's actually very, very effective for specific scenarios. Generally speaking, you need data that doesn't really update all that often and that quickly, maybe just a little bit more slowly. And if you have a scenario where you think this would fit, what you would do instead of going to the database to ask for the data every time, you know, you may start using some caching, etc. But if you're in different geographies, you'll have to synchronize your databases, or maybe not do that. Instead, maybe when you update the database, the one source of truth, you will also update some views that you have. And these views are basically select statements from the database that you persist somewhere else, and then you distribute that. So if you put that in Azure Table Storage in many locations around the world, for instance, or in blob storage, the same thing, maybe you store it as a JSON blob or something. When your application, you know, if it's in Australia or the US, or it doesn't matter, asks for the data with a known query, instead of going to the actual database and running that SQL statement and returning the results, the data set, you would go to, you know, blob storage and find that specific blob which contains that data. So you're distributing materialized views around the world instead. And distributing data like this, if you set that up properly, it's not super difficult to do, and it can be really, really cost effective, and it also scales really well. So you can just add n number of locations for that, and you're good to go. Architectural patterns like these, of course, you know, globalizing your data, all these things are things that we need to learn as developers, as cloud developers, or whatever that is. We need to learn them, and there is a really good site for it, the Azure Architecture Patterns, that you can go to. And there's a bunch of cloud design patterns there that you can just browse through. You should really read all of this stuff at least once. You open up your favorite Bing and write cloud design patterns or Azure architecture patterns, and you'll pop into this page. So definitely that's a tip. Now, I'm going to briefly mention Cosmos DB. It's already been mentioned, but what we are in is we are in a data explosion. Everybody agrees that's what's happening. Data is exploding continuously, and Cosmos DB is kind of Microsoft's design choice here to try to tackle this massive challenge of exponentially growing data sets. because you have this problem, right, that we have been talking about here. Either you have strong consistency and you get high latency because you have to go to the true source to get the data, or you get eventual consistency, but you can have low latency, so your application is fast, but maybe not always accurate. So those are the like the two problems here, and I don't know sorry. Let's go back to the. I thought I was on the slide. That's okay. There we go. The pills, that's what I wanted to show, right? So you get either or, right? And how do you do this, plus a bunch of other very strange requirements? Whenever there's a slide like that, remember again, this is for you to realize that, oh my gosh, that's a lot. So they tried to solve all these problems or tackle all of these challenges using Cosmos DB. And really, when you get into that, it becomes really, really complex, and you have to be like this dude to have like a white beard. And it's like, this is really, really complicated stuff to try to make your data not only easily distributable, but also available really quickly around the world. Cosmos DB, again, has these 4 APIs. I'm not going to go deeper into those. But what Cosmos DB does offer you, very, very simply, just literally pointing and clicking, gives you the ability to have your data available everywhere, right? You'll have to pay again for the copies of the data, but there's so much stuff that is just removed from your set of problems by using something like Cosmos DB. Your data will be everywhere just by the virtue of using the service. And what they are working very hard on, this is just one of those Microsoft example slides of competitive landscape here, is to guarantee really, really low latencies, both for reads and writes, even though you have this distributed model of data. And that's very difficult to do, and it comes back to, you know, the bearded guys really have to try to figure out how to do things like this. And I'm not saying specifically, well, I kind of am, but, you know, is Cosmos DB the best one of all of these competitors? Well, honestly, if you look at the numbers, if you look at the offerings, and if you look at what these things are capable of doing, Cosmos DB is in a really, really, really good place. The other ones are not bad, not at all. They are good offerings. You could use those. But Cosmos is in a good place and offers a lot. And Microsoft kind of wants to position this as a database for the next kind of 15 years of massive challenges with data, with IoT, with AI. That's the positioning of Cosmos. So I think it's highly likely that you guys will be getting into this unless you have already. Right. Final piece of the puzzle, and maybe honestly the most important one, and also the first one that you should implement, and traditionally also the thing that you kind of cram into the last few minutes of a presentation. Which, you know, I should have just started with this. But Azure, or the cloud, it is a measured service, okay? And I used actually some of the, did anyone see my presentation last year? A few, yeah. So a couple of the slides I'm reusing because the statements are so good. And this one is one that I really love, the quote by Dr. H. James Harrington regarding monitoring. It is like the essential quote. That's the quote to end all quotes about monitoring. Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. It is really that simple. I cannot tell you how many times I've come into a customer case, and Mark was talking about the exact same things, and the customers do not have enough, or maybe not even any, kind of an understanding about how their application performs. They don't have the metrics in place. It's so common. The simplified version of that is how the tailor puts it. You measure, then you cut. If you don't measure first, how do you know where to cut? You don't, okay? And for Azure, this is like a second PowerShell demo I'm going to run here quickly. For Azure, Microsoft are working towards enabling the same kind of monitoring capability for all the resources. Not all of them are there yet, and maybe not all of them ever will be, but many are, and they're onboarding more all the time. And so let's go back to PowerShell. It's actually quite fun. What you could do is run this save script with the name enable Azure RM Diagnostics. That will download for you a big script file which does this, and it's a 700 lines long script file, so all kinds of respect to the people who wrote that. There's a lot of comments in the file and some parameter stuff, and then it goes into all kinds of happy PowerShell scripting. But it is 700 lines of PowerShell, so I'm not going to like go through that in detail. Instead, I'm going to pull out sort of the essentials of that and show you that instead, okay? So I have some resources. You saw that earlier in the Azure portal. I have some resources that I have deployed. One of them is an OMS resource, a logging resource, right? The Operations Management Suite. And then I also have a storage account to which I'm going to do some diagnostics logging. I also have a web resource, so I want to monitor, in this case, a web application. So I'm going to get my resources. Once I've done that, let me show you this. I'm going to get my resources, and it's going to spit out the resource ID. And I want you to pay attention to this line here. It's big enough, right? Yeah. It says get-Azure RM resource. So I'm getting a resource from Azure as a general resource. I'm not treating it as a web application or as anything. I'm saying I know that all the things I have are resources. It's like they all inherit this base class of Azure resource, basically, right? So I'm just treating it as a resource. And then I'm spitting out the name of the resource down there. And actually, if you guys are keen after the session, I could tell you the secret about Azure, the real secret about Azure. So I'm going to leave it at that as a cliffhanger, and maybe we'll come back to it. If I pull out the diagnostic settings using the Azure RM diagnostic setting commandlet, I will get the diagnostic settings for this resource. In this case, we know it's a web application, right? So it seems I have enabled diagnostics for this resource. And again, this is not web application diagnostics. This is the implementation by that team for that type of resource, Microsoft.web/sites, that resource, their implementation of the general Azure Diagnostics implementation, okay? And I have enabled it already. I've set some metrics and retention policies and stuff. And as you can see here, I also have a workspace ID, which is my reference to this OMS workspace, to which my logs will now automatically be transferred. Okay? But what I didn't do, and the thing that I thought I would do here live, is that I haven't actually enabled logging to a storage account. So let's actually go and do that. It is really simple. Here's the storage account, so let's add that to the mix. I have my parameters there. I'm going to go and set the Azure Diagnostics, and then I'm going to read them back out again, or actually they return the result after they have configured it, and in the output. And then you look at that, and yes, I have now set a storage account ID, which tells Azure that diagnostics output for this resource shall go to this storage account. And then you can pull that from the storage account and start digging into the diagnostic trace or whatever it is that you want to do. So this is, again, general diagnostics because this is an Azure resource. It has diagnostics. And you can do this, and you should do this. And in fact, let me put it differently. You must do this. That's the first thing you have to do. You have to go and enable this. And I'm going to skip quickly towards the finish line here. I put up some additional screenshots just in case we ran out of time, which we're about to do. So I figured as much. But I want to mention that once you have this data, you can pull it up in Log Analytics, Operations Management Suite. It's funny because when you create that, the first sort of what is this blade says Log Analytics, and then when you hit create, it says OMS Workspace. So it's a little bit funny, but it's kind of the same thing, or I don't know. But anyway, there we are. So when you create that, this is actually a customer dashboard, so I have put some smudges on my image there so you can't see which customer it is. They're using Service Fabric, and actually the thing down there is a known bug, so it's not too bad. It's once you click on it, you'd still get the data. It's not a problem. So yeah, you get stuff like that into OMS, and from there you can do all kinds of alerting. For instance, if you have a health probe with an unhealthy state, you can get an alert email sent to people saying, oh my gosh, things are broken. The Azure Monitor inside of the Azure portal, though, is a really, really important place for you to go. The thing that looks like a little speedometer. You have to go to Azure Monitor and start clicking around these things and try to make sense of all these things in there. Super important place to go to. You can go and get the service issues. Is there a problem with Azure? When we're having a bad experience, you can go and find that in there. Something that we, the early adopters of Azure, have been asking for many years, which is now getting available for everyone, and it's in preview, as you can see. Planned maintenance, again, reference to the thing that we actually redeployed all of Azure a couple of weeks ago. All of Azure was redeployed because of this CPU-related bug thing, security flaw. All this information is in here, okay? We don't even have time to talk about the security center, but we will mention the alerts, because the alerts are super important. Now that you have the data, right? Now that you have the data, what do you do with it? You find the data, and you find the specific thing inside of the data that you want to have, and then you create an alert so that something happens when there is a problem. For instance, if you have a health probe saying that a service is down, well, that is something you can find in your log data. Once you find that in your log data, you create an alert that says, whenever this happens, send me an email or send me a text message or whatever that is, okay? Super important. So in conclusion, you need to have an Azure resource owner for your resources. You have to have that. When you have Azure, when you have a serious deployment in Azure, somebody needs to own it. It could be a person or a team, but somebody needs to take responsibility. You shall deploy using ARM templates. Thou shalt do that for environmental equality between different environments. QA and production has to be the same. Otherwise, what are you testing? You monitor your management API audit logs and see who does what to what. That's important. And you apply the principle of least privilege all the time, okay? So, my time is out. Good, because I'm at that slide, which is the same that you've all seen before. And let's end on this note saying that, this is an anti-pattern that I devised. From experience, I've seen this happen so many times that people are afraid of flying in the clouds, and what they do instead is they keep kind of one toe on the ground, and then they try to fly at the same time, and that ends up in a scenario like this. If you have both things on the ground and in the cloud, the problem is that for the duration you have that, you have made your surface attack area and all of your problems twice as many. So go to the cloud, have fun. You don't have to start really big, but you can start with a small thing. Just deploy something simple and get going and move on from there. So that was it, and I'm shamefully plugging my Azure course that I have in case you want to have a real understanding about what Azure really, how it really works. That was it. I'm over my time. Thanks for listening today. Appreciate your attention.